Open circuits in a Y three-phase system with a neutral conductor. In this presentation, we're going to look at why the neutral is so important. And on a Y system, the neutral is so important because it maintains phase voltage value, no matter what the balance or unbalanced nature of the system is. Now, what I mean by that, well, let's take a look at a full three-phase Y system and introduce a few open line and open phase situations. So here we have a common three-phase four-wire system, and we've got varying values of impedance. So different current values will be flowing through each of these three loads, but each one has 120 volts across it. Now, what would happen if one of these was removed? Well, if we remove this from the circuit, notice that my 8 ohm and my 15 ohm still have a connection back to the neutral. And remember, the phase voltage is measured from the line to the start point. So effectively, the 8 and 15 ohm have been completely unaffected. Well, what if we instead removed the C load? Well, same situation. We find that the 12 and the 8 ohm remain unaffected. They have no idea that something's been removed. And this is what happens in a large commercial or institutional setting where loads are continually being turned on or off as people utilize the facility. Lights going on, lights going off, motors turning on, motors turning off means that the load is continually varying on all three phases. Since we have a neutral, if at any time the entire phase load is dropped to zero because it so happens that there is no loads energized at that moment, the remaining two phases see no effect. So what about an open line condition? Well, for the individual loads, what if we had a blown fuse? If C was blown, well, that would then mean that now my C phase would see absolutely 0 volts. So now we have 0 current flowing through the 15 ohm resistor. What about the remaining 8 ohm and 12 ohm? They saw absolutely no difference. Well, what if instead we saw that A phase fuse or A line fuse was blown? Well, same situation. There would now be no voltage across that individual load, or all the loads, I should say, on the A phase, but B and C would continue to operate as if there was no problem. Now, this, of course, is disregarding any implications that would have three-phase loads connected, like motors and things like that. Of course, there would be some single phasing that would happen in those items. But for these, they're largely unaffected. So what this means is that regardless if it's an open line or an open phase, the remaining phase voltages remain unaffected. This would mean also that the remaining phase currents are unaffected. The neutral current will change based on which loads are connected. And that makes sense because as soon as I remove one of these entirely from the circuit, well, obviously the unbalanced nature of the circuit changes and therefore the neutral current would change. Well, let's take a look at how this would then be affecting on a large system if we had an open neutral. Now remember, open neutral conditions in a single phase system with an Edison three-wire have pretty severe consequences. So in reality, we don't have resistors, but we have various objects that are connected. So I got a single phase TV, I got some lights, I got a motor. And currently, all of the items, because we have a 120 208 volt three-phase system, are connected in the phase, and they are each getting 120 volts. Now, what would happen if instead of an open line or an open phase, we had an open neutral? Well, if the neutral goes open, phase voltages go crazy in much the same way that the voltages in a single phase system go all over the place. They are going to be based on the relative impedance per phase. And so what this means is that each of these loads is now going to get a different voltage. Some are going to be very low and some will be very high. And it will really depend on how many loads are connected into A, B, and C. It's a bit of a game of Russian roulette. It's extremely bad. And since 99% of all Y systems will be unbalanced because that's what our main buildings are actually supplied with, it's incredibly important that we never have an open neutral.